Well, hi, thanks so much for joining me as we talk about our practice problem number 24 here. Hey, let's see what's going on in this problem. So let's see, we've got Sarah, and Sarah regularly flies from Geneva to London. So there's cities over in Europe. She takes either a direct flight, which means it goes straight from one city to the next, or a non-direct flight, which means it stops at other cities on the way. It goes via Amsterdam, so it stops at Amsterdam. So she either goes direct from Geneva to London, or she goes from Geneva to Amsterdam and then to London. Now, if she takes a direct flight, the probability that her baggage does not arrive in London is 0.01. If she takes a non-direct flight, the probability that her baggage arrives in London is 0.95. The probability that she takes a non-direct flight is 0.2. Okay. I don't know if you've ever traveled by airplane before. I have. And man, let me tell you, my baggage arriving, that always stresses me out. Like getting off the plane and going to pick up your baggage and just hoping that it actually comes out and that they didn't lose it somewhere. So if you fly, this is pretty valid. And if you fly in the future, this is also pretty valid. So let's see what we got going on here. Well, all right, so they've started a diagram for us. So let's look at this because this is something we haven't talked about yet, is the order. Notice she has to fly first before she gets her baggage. So a lot of times, order in your tree diagram matters. Like, the first thing she has to do is she has to fly. And then she has to see if her baggage made it on time. Okay? Notice, we can't switch these. We can't say, hey, did your baggage make it? And then get on the plane. Like, that doesn't make sense. You have to get on the plane first, and then you get your baggage. You can't get your baggage and then, like, backtrack and then get on the plane. So, order in this case matters. We have to know what flight she took first, and then we can figure out what happens to her baggage. So from the problem tells me that the probability she takes a non-direct flight is 0.02. By the way, part A says complete the tree diagram, because I'm about to dive into that just because that's a reasonable thing to do. But in reality, I'm actually doing part A, complete the tree diagram. So if you remember from previous videos, any of the branches that have the same vertex, so any branches that have the same starting point, do you remember what they have to all add up to? Do you remember? It's gotta be 1. So if a non-direct flight is 0.2, what would the direct flight have to be so that we add these together to get 1? Well, really what we're doing is we're going 1 minus 0.2, and that gives me 0.8 up here. So now 0.8 plus 0.2 is going to give me 0.1, or going to give me 1. So let's see what else I've got. Well, down here, again, here's another vertex. So I know these two branches also have to add up to 1. So one of my branches is 0.95. So what's the other branch have to be so that these add up to 1? Well, this is going to be 0.05. And I didn't put this explicitly, but just like over here, we did 1 minus. So we do 1 minus 0.95, and that's going to give us our 0.05 down here. Now, how about this last branch? Because they don't have either one of these filled in. Well, I'm going to go back to my problem and let's see if it gives me any help here. So, if she takes a direct flight, if she takes a direct flight, well, notice here is a direct flight. So, these two probabilities are based on Sarah taking that direct flight. Tree diagrams, it's kind of like if you're climbing a tree from the ground, like you can't just, we don't live in a Harry Potter world. We can't just like apparate ourselves up into the top of the tree. We actually have to climb each branch of the tree. Same thing with the tree diagram here. Like we can't just magically jump over to the baggage, we have to start at the beginning and we have to work our way over. So in order to get to this vertex, we have to take the path that is the direct flight. So we know that this is based on a direct flight. Well, okay, if she takes a direct flight, the probability that her baggage does not arrive, okay, so that's no baggage, so I have direct flight, no baggage, is 0.01. So my 0.01 is going to go down here. And then, again, notice these two branches share the same vertex. So what are we going to put up here? Well, if you go 1 minus 0.01, you're going to get 0.99. And there we have our completed tree diagram. So now from here, go ahead and try parts B and C. Give them a try, see what you come up with, and then come back to the later videos and check your work and see how you did.